Hey guys, what's up? It's me. I'm not here today. I'm down the road at a district for Math 2 training, and it's on Pi Day, which is unfortunate. I was going to do some like circle-y pie related activities. Hopefully I'm eating pie right now. We'll see. Anyway, sorry I couldn't be there. Wish I was there rather than where I am right now. Thank you to whoever is letting us use your Chromebook to look at these videos. Not just this video, but I'll post a video in the description or a video right here, maybe, to a video to help us do what we're going to do today. All right. What we're going to do today is basically what we did on Wednesday. We're going to be trying to complete a square. We can start by using algebra tiles, but towards the end, we're going to want to do it without algebra tiles and just generalize, kind of like maybe using an area model, or you can even do it without an area model, depending on how you understand it. All right. So once you grab this piece of paper, it's going to look a lot like a piece of paper you had yesterday, but this one has a picture of some people playing with algebra tile and some algebra tiles down here. Make sure you have this one. And this one is a class set. I don't have 180 this time. So if you can just use this and don't write on it, just, do the work in your notebook. That would be superb. Later in the class, you'll have this classwork and this exit ticket. This exit ticket right here, you're turning in. This one is for you. I want you to practice that. I can check it, stamp for it, give you credit for doing it, but this one I want you to turn in and go in the grade book separately. This is to help me see how well we're doing, all right? Because I'm not there. I can't see how well we're doing, so this will help me, all right? Do your best on that. So let's start. I want to help you guys do the first one. All right, so this piece of paper says, now we will generalize how to complete the square for any quadratic equation written in standard form. Sometimes it's going to be numbers too big to use algebra tiles and stuff. So the first one says, solve each equation below by completing the square. You can use algebra tiles. You can draw a diagram to represent the tiles. Write your answers in exact form. If you write them in approximate form, whatever. Then explain how to determine how many solutions it is. So let's just start by completing the square. This is where we were on Wednesday. You see here I have the first problem, x squared minus 6x plus 7. So I have x squared, 6 negative x tiles, and 7 1 tiles, right? The red side means it's negative. So I'm going to make a square out of that. I'm going to try and do my best. I know this might be backwards on the video. I don't know, but it's all good. Here's a square, right? And if I'm trying to make a square with that, I got these 7 tiles. Let's just start going. Let's put them in here. Let's go. 1, 2, 3, 4, 5, 6, 7. There we go. Not quite a square, right? You're almost there. I'm going to put you down. I have this almost square here. The dimensions are x, -3, x, -3. I know -3 times -3 is going to be positive 9. I'm going to have 9 positive 1 squares in here, right? Can you ever have a square with negative 1s up here if these sides are going to be the same? Now, I'm going to make this square. Turn this into a perfect square. I want it to end up being x minus 3 squared. But it's not quite equal to that, right? It's not quite x minus 3 squared. What do I got to do? Well, I got to add a couple. So I'm going to add 2. But if I add 2 to this to make this, then I'm going to have to add 2 to that too. And I'm not trying to change it. So if I'm not trying to change it, and I added 2, I had to make up for that by undoing it. By just adding a little remainder out here. -2. Bam. So we realize that this is the same. I'm just putting these right here so I can complete this square. And I have that this, what I had originally, is equal to x minus 3 squared minus 2. A lot of people also like to see it like this. We know that x minus 3 squared is x squared minus 6x plus 9. X squared minus 6x plus 9, right? This is x squared minus 6x plus 7. Well, what's the difference? The difference is that this is just 2 less than that, right? So if you take x minus 3 squared, subtract 2, you get that. That's another way to think about it, right? So again, there's a way to do this algebraically. And instead of me going over it right now, post a link in the description so you can see that too, or in the description. Be sure to like and subscribe if you want some great math videos that won't actually be that great. Anyway, do your best on that. After you do these three right here, with any method you want, this next one is going to have bigger numbers. So like it'd be hard to use algebra tiles. X squared plus 24x plus 63. You're going to have to use an area model for that, man. Like those tiles are going to be annoying to use that many. All right. And 85 is really good. I really want you to read that as a group. Facilitators, do your job. Read the problems to your group. Everyone should be a part of that problem. That's a good problem. All right. What do you do when you're given an odd number of X tiles and you're trying to make a square? Good stuff. All right. There's classwork and a learning log that I've included on the classwork. I'd like you to write that in your notebook. That'd be awesome. And then this exit ticket. Just do this like the last 20 minutes. There's homework in the back, 523. You might have time to work on that too. I'm going to miss you. Watch this video in the description if you need help doing it algebraically. You might want to follow along with this person. And if you want another example, he does another example in another video. But I think the first one's probably good enough for you guys to get started, all right? Bye.